Ask a frontier model to solve a problem from the 2022 International Math Olympiad, and it will likely nail it. But pause for a second. Did it actually solve it, or did it just retrieve a solution it saw during training? This is the crisis of modern AI evaluation. We are trying to measure reasoning with a ruler made of memory. To fix this, 11 mathematicians, including Fields Medalist Martin Harrer, launched a radical experiment scheduled to end in February 2026.
We call this data contamination. The internet is the training set. Every Stack Exchange answer, every archive preprint, every forum discussion, it's all been ingested. If a math problem exists online, the model has likely seen the answer key. This makes fair evaluation impossible. You cannot test a student's reasoning if they've already memorized the test. The first proof team realized that solving this requires something unprecedented, questions that have never touched the digital world.
The name first proof comes from baking. In bread making, the first proof, or bulk fermentation, is when you let the raw dough rise as one chaotic mass before dividing it into loaves. The authors use this metaphor deliberately. This paper isn't a polished benchmark. It is the raw dough. It is an unstructured experiment designed to let the community ferment ideas on how to properly test mathematical creativity before we try to standardize it.
Most AI benchmarks rely on contest math, Olympiad problems designed to be cracked in 90 minutes using known tricks. But real research is fundamentally different. The authors identify 3 pillars of mathematics. First, figuring out which questions to ask. Second, inventing the definitions and frameworks to ask them. Third, proving the statement. Contest math only tests a tiny fragment of Pillar 3. It misses the months of exploration, the dead ends, and the structural insights required for actual discovery. The paper presents 10 research-level questions spanning fields like symplectic geometry and spectral graph theory. These aren't textbook exercises. They are actual unpublished lemmas from the author's own work. Question 1 asks if a shift map on the 543 measure over a 3D torus produces equivalent measures. Question 6 asks if every graph contains a sufficiently large epsilon light subset relative to its Laplacian matrix. These are the stumbling blocks of modern mathematics, solved by humans but never written down online. The experiment's integrity relies on absolute secrecy. The authors encrypted their proofs and posted them to firstproof.org. The decryption keys are held offline and will not be released until February 13, 2026. This creates a perfect zero-shot environment. The AI cannot look up the answer because it exists only in 2 places, inside the encrypted file and inside the mathematicians' heads. No public forum, no preprint, no conference talk has ever contained these solutions. The team tested these questions against Gemini 3.0 DeepThink and GPT 5.2 Pro. The protocol was strict. 1 shot, no iterations. The result? The models failed. But this revealed a paradox. The act of testing itself creates contamination. Even with data sharing disabled, OpenAI retains chat logs for 30 days. Google can retain human-reviewed conversations for up to 3 years. Every time you test an AI on a secret problem, you risk teaching it the answer for the next version. How does this compare to other efforts? Frontier math uses hidden problems, but they resolve to integers for automatic grading. Real math scrapes archive, but it's fighting a losing battle against web crawlers. First proof is unique. It checks 4 specific boxes. The questions come from the true distribution of research. The answers are proofs, not numbers. The questions are public, but the answers are encrypted. And finally, models get full access to external resources, just like a real mathematician.
The authors are clear-eyed about the limits. This experiment only tests the 3rd pillar, proving well-formed statements. We still don't know if AI can ask the right questions or invent new theories. But the signal is clear. When you strip away the training data and force genuine zero-shot reasoning, frontier models struggle. The answers will be revealed on February 13, 2026. Until then, these 10 questions stand as an open challenge to our understanding of machine intelligence.